Today, we're going to learn how to find the domain and range from a function. So you should be on page 44 in your notes packet. When we're looking for domain and range, what you always want to look for are the x and y values in your graph. The domain is going to be all of the possible input values for a function. Those values are also called the x values or the independent variables. So when you're looking for domain, you are really just looking for these x values that represent your function. When you have a set of ordered pairs, you want to look for all of the x values in those ordered pairs. In the first example, you see that you have an x value of 0, an x value of 1, an x value of 2, and an x value of 3. When we're writing domain or when we're writing range, we want to put them inside of brackets to represent that that is all of the x values that represent that particular function. And you want to make sure that they are listed from least to greatest. So if I were listing all of the x values from the function shown in number 1, I would list them as 0, 1, 2, 3, and notice that they are inside brackets and there is a comma separating each of them. For number 2, if I'm going to represent the domain, again, domain is all of the inputs, which means you're looking for your x values. So this ordered pair has an x value of -1. This ordered pair has an x value of 0. This ordered pair has an x value of 1. And this ordered pair has an x value of 2. So I would put them in brackets again and list them from least to greatest. So this would be -1, 0, 1, and 2. Although you don't see this here, you do sometimes see instances where you may have a number that repeats. So if you have a domain or a range that has a number that repeats, I want you to make sure that you know that you would never repeat your values. So this might be an instance where you have a function that says 0, 1, and then 0, 2, and then 0, 3. And actually, this would not be a function, it would be a relation. But if you had to tell me the domain, the only number that is in the domain is 0. So that is the only number you would write. Now let's look at the table. If you have a table and you need to find the domain of that function, again, you're only looking for x values and you're listing them from least to greatest. So your x values here are -1, 0, 1, and 2. So again, you list them in brackets with parentheses or not parentheses, commas separating them. For number 4, your domain is going to be 0, 4, 8, 12. When you have a graph and you want to find your domain, remember you're still writing them in order from least to greatest. So the best way to do this is look at the points and read them from left to right. So you're finding the x values and you are finding these from left to right. So if I go furthest to the left on my graph, that's this point that's down here. Well, that point, if I looked from the origin, is left 1. So that is an x value of -1. Then my next point is here. Well, this from the origin does not move left or right, so that is an x value of 0. My next point is right here. So from the origin, that moves right 1, so that's a +1. Then I have this point, which is right 2, so that is a +2. Then I have my next point, which is right 1, 2, 3, so that is a +3. And then I have my last point, which is right here. And from the origin, that would be right 1, 2, 3, 4. So that is a +4. If I wrote this as the domain, I would again write it inside parentheses and with brackets, or inside brackets and with commas separating them. So it's -1, 0, 1, 2, 3, 4. For number 6, My point that is farthest to the left is this point right here. So if I looked at that from the origin, I would have to move left 1, 2, 3, 4, 5 units. So that would be -5. Then it's this point, which is left 2 units, so that's -2. Then this point, which is right 1, so that's +1. And then this point, which is right 4, so that is +4. So I would write this as -5, and that's supposed to be a -2, sorry. -2, 1, 4. For range, the range is the set of all possible output values, which means for range, you're looking for all of the y values. And another word for that is dependent variables. If you have a set of ordered pairs, your y value is always the second value in your ordered pair. So this would be 4, then 5, then 6, then 7. Well, again, you list them from least to greatest. So this one would be 4, 5, 6, 7. For number 2, you have -5, -2, 1, and 4. For number 3, your y values are these values right here. So 5, 2, -1, and -4. Well, a big mistake that people make is to write it just like this, 5, 2, -1, -4, because this is just what you see. But remember, it has to be written from least to greatest. So if we take these and actually write them from least to greatest, it would really be -4, -1, 2, 5. For number 4, if you wrote your y values from least to greatest, you would have 2, 3, 4, then 5. In a graph, when you're looking for range, if you're doing this from least to greatest, you use the lowest point. So go from bottom to the top and look at just the y values of those. In number 5, my lowest point is this point down here. Well, the y value is how far down it is from the origin. So if I count it down, that's down 1, 2, 3, 4, 5, 6. So that would be a -6. My next point is right here. Well, that is down 1, 2, 3 from the origin. So that has a y value of -3. My next point is right here. And actually, from the origin, I wouldn't have to move up or down, which means that this has a y value of 0. My next point is right here. So if I was counting that from the origin, I would move up 1, 2, 3. So that one would have a y value of +3. And then my last point is up here. So from the origin, I would go up 1, 2, 3, 4, 5, 6. So that would have a y value of +6. So again, you would need to make sure that you wrote those in order from least to greatest and in brackets. For number 6, if you look at those numbers in order from least to greatest, you would look at your bottom point, which is this one right here. So from the origin, you would have had to go down 1, 2, 3, 4, 5, 6. So this is going to have a y value of -6. Then you have this point, which is down 1, 2. So that's -2. This point, which is up 2. So that is +2. And this point, which is up 6, so that's +6. So the range for this would be -6, -2, +2, +6.